also known as a 68, 95, 99.7 model. Now, we are going to be studying a specific type of distribution. All right. So when we talk about a distribution, and describing a distribution, a quantitative distribution, we talk about SOCs. And then of course we also have to include context. So we have shape, outliers, center, spread. Now we're going to study today a very specific type of distribution. All right. So we're going to be studying we're going to be talking about unimodal and symmetric with no outliers are a very special distribution. Within this classification. So we are really focusing on here unimodal and symmetric, no outliers. If a distribution is unimodal and symmetric with no outliers, I want to point out that because of this, we just need to state what the mean and the standard deviation is for center and spread. Okay? If a distribution is, remember, those are symbols for mean and standard deviation, which I have talked about. If a distribution is unimodal and symmetric with no outliers, we have a special distribution called the normal model. Normal distribution is a unimodal and symmetric distribution that follows excuse me, the 68, 95, 99.7 rule. The empirical rule. Now, this is something that I get a lot of students that are confused about. A lot of students think all distributions that are unimodal, after we get into dates, I get a lot of students who think that all distributions that are unimodal and symmetric are normal. False. I get a lot of students that also try to think that all distributions that are unimodal and symmetric are therefore approximately normal. False. Unless a problem specifically states normally distributed, all right, we deal with and refer to as approximately normal. Now, later on in this course, there are rules to determine if approximately normal later in the course. All right. So later in the course, they will not tell you approximately normal. They will not tell you normal. They will say approximately normal. They won't. They will. There's that will happen later in the course. However, right now, it's important to note that for now, will be stated normal. We use a capital N, or approximately normal. We use a squiggly line in front and then the N. Okay. So in statistics, the capital N stands for normal, the normal distribution, which means that the distribution follows the 68, 95, 99.7 rule. I'm going to tell you what that is very briefly. It means it follows that it is unimodal, symmetric, and it follows the 68, 95, 99.7 rule. Now, no, I know I didn't state the idea of no outliers. Let me update with typically no outliers. Typically, sorry, I don't want to say that there are no outliers, because the 68, 95, 99.7 model, technically there could be some outliers, but that means because you have so much data, there's really not going to be outliers. So when I say something is normal, I am telling you that the distribution is unimodal and symmetric, and it follows a 68, 95, 99.7 rule. So because of that, when you state normal or you state approximately normal, you have described shape. Well, these describe shape, yeah. So when you say normal or approximately normal, you've told me the shape. You still must state the mean and standard deviation. We call the mean and standard deviation the parameters for the normal distribution. So these are the parameters. So what are the parameters? The parameters are the mean and the standard deviation. But of course, specifically for that problem, the parameters are the center for that distribution and the standard deviation, the spread of that distribution. So you can't just tell me, if you just said the distribution is normal, you have not described the distribution yet. First off, it's missing context. If you give context and you state that it's normal or approximately normal, then you still have not finished describing the content or the distribution, because you're still missing the center and the spread. So typical notation is n mu sigma, or approximately normal, mean, and standard deviation. This is typical. This is recognized in AP statistics. So this tells me shape. This tells me the center. This tells me the spread. All you need, of course, is context still needed. I prefer normal and state mu equals standard deviation equals. I prefer you to write it like this and then write in the values, because a lot of you, especially as we begin to do this topic, will write which one's a mean and which one's a standard deviation. So it's typically better to write mu equals. There's a lot of parts later on in this course where if you don't write it, because you're not going to write normal, you're going to do something like normal CDF, as we'll talk about tomorrow's class. And when you do that, we don't recognize that as proper notation. We recognize it as calculator talk, and therefore you never stated the mean and standard deviation. So as such, I prefer you to actually state the mu equals and the standard deviation equals. It is appropriate just to state the two values, i.e. normal 5, 10. I would write this as normal mu equals 5, the mean equals 5, and the standard deviation equals 10. Okay, so I prefer this. I prefer this right here. This is preferred, but it's not required. If you just wrote this right on the left-hand side, that's good enough, as long as you include, of course, context. Who and what. So who are we referring to, and what is the variable? Drawing the normal distribution. All right, so please take the time. You need to have paper out on yourself. You need to make sure that you're practicing drawing this. Typing this into a computer is not going to help you. Utilizing the feature in like try to use a copy paste is not going to help you, because you need to be able to draw this by hand to everybody. So when you draw the distribution, it should be like, it's like a plane taking off and then landing as soon as highest point reached. So think of the plane, an airplane, okay? So when I draw it, I'm on the runway. I take off, and then I come back to land. Okay, so the plane is taking off, and then notice that planes do not go vertical. Okay, planes do not go vertical. All right, so that's how you're going to have it right there. Drawing it like this, woo, that's a big no-no. Now we call that the cousin it, or the ghost. This is normal. This is paranormal. Woo. All right, that's a ghost right there. That's the cousin it. That's the ghost. That's paranormal. We want to draw normal distributions, not paranormal distributions, people. And no, paranormal is not an actual statistical word. It's a little pun or joke. Halloween just did happen. But if you draw your distribution like that, you're going to lose credit. That is not normal. Some people will draw it like this. No. Planes cannot do that. All right? Planes cannot just go up and then just, that means it probably crashed. The plane probably crashed in that case. If it just all of a sudden, it was going up and then, no, that does not work. We'll get ones that look like a parabola. I'll get ones that do this. Now that's a quadratic. I don't know what that is. No plane can take off. It's like a plane is just like, that's more like a Rocket Man type of thing. You're just gonna get shot out and fall, right? You're throwing some type of thing. That is a no. These are unacceptable versions of drawing the normal model. You draw a normal model like that, you can expect to get taken points off. Okay. Now, how do I describe this distribution? How do I describe this distribution right now? This distribution is what? As is.
Normal.
Close. It is not the way I've drawn it so far. So far, I can only say that this distribution is unimodal and symmetric. This does not define a normal model. To make it normal, there has to be a special property that goes on within here. And so normal distributions, remember, follow the 68, 95, 99.7 rule. And here's what that rule means. If these are the z-scores, let's say that these are the z-scores, okay? Or actually, let's not even get to there yet. So the mean of the distribution is right in the center, okay? So for a, and that's true here as well. The mean is right there. In statistics, and I told you, I gave you this hint before, I said that the standard deviation typically occurs where the inflection point is. So somewhere right around, and I guess this, the way I drew it is a little bit off, but typically somewhere right around here is what we refer to as a standard deviation. So the distance between here and here is a standard deviation. Or actually, I don't want to draw it like that. So that means that this distance between there is a standard deviation, and I'll draw it. And therefore that. So that's how we measure on our graph of a normal model, or of a unimodal symmetric distribution for how, wrong symbol. Okay, it's one standard deviation. So this value here would be of the mean plus a standard deviation above. And this value here would be the mean minus a standard deviation below. And I would keep going on terms of over here. That is another standard deviation. 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 So this is the mean plus 2 standard deviations. This is the mean plus 3 standard deviations. This is the mean minus 2 standard deviations. And this is the mean minus 3 standard deviations. Now, these are going to be actual numbers. All right, they're going to be actual numbers. So I'm going to tell you, like, the mean is 100. And the standard deviation is 10. So it'd be 100, then 110, then 120, then 130 going to the right. Or going to the left, it'd be start at 100, and then it would go to 90, then it would go to 80, and then it would go to 70 on the left. Okay? Now, I guess I should have drawn that on top over there, but oh well. So that's that part right there. Now, what makes it normal? And I'm going to redraw this again because it is very problem. Now, when I say the 68, 95, 99.7 model, it means that between one standard deviation between, we expect, or we get 68% falls between, so when I say this, I said 68% of the data falls within one standard deviation of the mean. Okay, 68%. So we would expect which is a lot, which is most of our data. 68% is over half. Most of my data falls between one standard deviation of the mean. How much do you think falls between two standard deviations of the mean? How much do you think falls between two standard deviations of the mean? Of the data.
Is it 95?
Yep, 95 what? Percent. Yeah, 95 data of percent falls within two standard deviations of the mean. Now that's most of the data, right? So 95. So if you were sampling, and this is what happens when you're doing things like polls right now. It's election day, and everything is actually built on the normal model. And I wish we could have gotten through more material so that when we got to this election, I could explain to you more. But basically, what happens is that data is taken, and because of the way that the data is taken, we can actually use an approximately normal model. All right. So because we use an approximately normal model. This property happens, and when they talk about and they say like Joe Biden has 52% of the votes within for this state right now. That's what he's polling at, 52%. But he doesn't mean he's going to win. That's the mean. The mean is 52% of the votes. All right, and there's a window. That's 52%, but maybe over here, if this is 52%, for example, this over here can be like 42%, and this could be 62%, okay? And what I mean by there is that while we expect him to get 52%, it wouldn't be unusual for him to get 42% to 62%. Anything beyond that would not be unreasonable. Now, typically, that's Typically, they utilize 3%. So if this was 52%, when they talk about those polls, this is usually this would be 49%, and this would be 55%. So when they say that Joe Biden is polling at 52%, and they're saying that's not enough, he's within the margin of error that Trump can win that state. It's stating that if in the end Biden only gets 49%, it wouldn't be unusual for him to get 49%. All right, because that's within two standard deviations of the outcome. We're going to get into a lot more about it later on when we get into things called confidence intervals, which I had heard that Miss Kogut in her biomath stats had introduced confidence intervals, but it's based on this idea of the normal model. So she had asked me yesterday about it, if anybody could explain confidence intervals in her class. I told her that I was going to introduce the normal model today, and that could be something of a base understanding of it. But that's how it works. And finally, how much data would we expect within 3 standard deviations of the mean? Do another different color here. Brown. I'll go brown. How much data would I expect within 3 standard deviations of the mean? Look at the name of the model.
99.7.
99.7%. So you would, which is virtually all, right? Virtually, I can't even spell virtually. 95% is most, and 95% is majority. I would expect the majority of the data to be between a standard deviation. I would expect most all to be within two standard deviations, and virtually all. So if you're more than 2 standard deviations above the mean, you're outside the middle 95% typically. If we're using a normal distribution, if you scored two standard deviations above, then you are technically, outside the middle 95%, which means you're either in the top 2.5% or the bottom 2.5%. Okay. 99.7% of the data falls within 3 standard deviations of the mean. Okay. So let's draw another normal model. Let's draw this again, okay? We're going to draw the same idea. I'm going to try to clean it up a little bit. And we're going to add some other parts to the data. So here's my number line. Woo, takes off. Woo, lands. It's good enough. Not paranormal. Close. Maybe I could liken out that right side, but I think that's good. So, once again, this is the mean. What I like to do in terms of drawing this is typically what I do is I just take the end and I chop it off, like right around there, and I'll chop off a part over there, and then I split the middles, and then I add one more line about equal distance around. Okay, this is once again the mean plus the standard deviation, mean plus 2 standard deviations, mean plus 3 standard deviations, mean minus the standard deviation, mean minus 2 standard deviations, and mean minus 3 standard deviations. And I expect to see 68% between 1 standard deviation, 95% between 2 standard deviations, and 99.7% within 3 standard deviations. Now, where I drew these lines, I drew them like above. You could have drawn them below like this. You could have drawn them like this. That would have been appropriate to do. And if you wrote them like that, you just got to show me the distance. So when I say draw, you need to show that 68, 95, 99%. That's the biggest key takeaway. When you draw it, you need to state that in there. If you don't put 68%, 95%, 99%, 99.7%, if you don't show that with where they fall, then you have not drawn a normal model. You have just drawn a roughly unimodal and symmetric model. Now, we can add an extra number line here, where this number line, this will represent the actual values, x. The other one will represent the z-scores. Okay, so what is the z-score for the mean? If you are the mean, what is your z-score? Based on yesterday that we learned, or the day before too, the class before.
0.
0, good. If you are 1 standard deviation of the mean, above the mean, then what's your z-score?
+1.
Good, and then 2 and 3. If you're 1 standard deviation below the mean, then you are?
-1.
And 2 standard deviations below the mean?
-2.
And finally?
-3.
-3. Okay. Percentiles. All right. Percentile means percent below. All right. If you are the mean, how much of my data is below 0? Will be below the mean. How much of my data is below? Well, how much is above and below? Like, what does the mean do? If it's symmetric, how much of the data is chopped off? How much data is below the mean? This is the, if it's symmetric, think about it, it's symmetric. How much of the data follows over here? How much of the data is over here?
50%.
50%. So we call this the 50th percentile. If you score the mean, the average, you're in the 50th percentile. Okay? Now comes a little bit of math. All right, so 68% is right in here, right? If 68% is here, how much is left over? What percentage is left over? If 68% falls between here and here, how much is left over?
32.
32%. So how much, if 32%, and how much is below over here then?
16.
Perfect. So this would be considered the 16th percentile. And I'm just going to write the rest. The 84th percentile. This would be the 2.55th percentile. This would be the 0.15th percentile. This is the 97.5th percentile. And this is the 99.85th percentile. I'll explain a little bit more about these. I wanted you to at least to get these on. We will continue tomorrow. I'm not going to assign any homework because I need you to practice a little bit more, and this is very important. So I'm going to update to no homework. Don't worry about it too much. Just make sure you grasp this. So for those of you who are having tutoring tonight, make sure I really need this part right here. So for those of you that are going to tutorings, I need you to understand the premise of this. So I would highly recommend for those of you at tutoring, and I'll send this, I introduced them. You want to have a solid understanding so that when we get into tomorrow, we're going to do a little bit of more of the calculations. I'm going to shift everything by a day. It is 9:50. Have a good rest of your day.